In this video, we're going to talk about some trigonometric identities and how to prove them. So let's just start with the ones that we know. Okay, so there's the standard quotient identity. So that's just the definitions for tan. Let me just do it like this. I didn't leave myself enough room. So we have our quotient identities. Okay, so that's the fact that tan theta is sine theta over cos theta. Cotan theta is cos theta over sine theta. Secant theta is 1 over cos theta. And cosecant theta is 1 over sine theta. Okay, we also have our even, or odd, let's do the odd ones first. So the odd functions, so this gives us an identity. Okay, so we know that sine is odd, so sine of negative x is actually negative sine of x, or theta, I guess. Maybe I should switch and use theta the whole time. Okay, tan is also odd, so tan of negative theta is negative tan of theta. Cosecant of negative theta is negative cosecant of theta, and cotan of negative theta is negative cotan of theta. Okay, and then we have our even functions. Okay, so that's just cosine of negative theta is just cosine of theta, so not negative, but it's equal to the regular cosine. And secant is also an even function. So secant of negative theta equals secant of theta. Okay, and then we also have our Pythagorean identities. Okay, so the main one, sine squared theta plus cos squared theta is 1. And then by dividing everything by sine squared, I get 1 plus cotan squared theta is equal to cosecant squared theta. Or if I instead divide everything by cos theta, I get tan squared theta plus 1 is secant squared theta. Okay, so those are ones that we've already seen. Okay, now in this section, we're going to be using these as well as finding others. So when you simplify a complex trigonometric function, there's several techniques, but what you end up getting is an identity. So the beginning function is equal to your simplified one. So let's start with this example here. So the technique number 1, maybe I should just emphasize these. Okay, so technique number 1 is convert all of the non-sine and cos functions to sine and cos. Okay, so that if you don't know what to do, that's always a good thing to do. So here, if I wanted to simplify cotan theta over cosecant theta, I don't really know what to do. So I'm just going to change everything to sine and cos. Okay, so cotan theta over cosecant theta. Well, cotan is cos theta over sine theta, and cosecant is 1 over sine theta. Okay, now I have a fraction over a fraction. So if I'm dividing fractions, what I want to do is flip the bottom one and multiply instead. Okay, so then I have cos theta times sine theta over sine theta, and the sine thetas can cancel out, so I just get cos theta. Okay, so then you could say this thing is equal to cos theta. Okay, so that's what it simplifies to. The second technique that we could use, technique number 2, is to use the Pythagorean identity to simplify. and it says a non-standard form. It doesn't have to be non-standard. What they mean by that is that you can rearrange those formulas to use them any way you'd like. Okay, so for example, the sine squared plus cos squared formula, I could solve for cos squared, so then it would be 1 minus sine squared. Or maybe I have cos squared minus 1, and if I solve for that, I get negative sine squared theta. Okay, so you can use them any way you need to. Okay, so let's try this one here. So I want to simplify sine squared x minus 1 over cotan x. Okay, so because I see a 1 and a sine squared, I'm thinking maybe the identity can work. So I have this, and I want to solve for sine squared x minus 1. So I'm going to subtract 1 on both sides. That's going to get rid of that. And also subtract cos squared. So sine squared theta minus 1 is negative cos squared theta. Okay, so I can use that. So sine squared x minus 1 is going to be negative cos squared x. Okay, so the top simplifies to negative cos squared x. And then I have it over cotan of x. Okay, now maybe I can simplify this more. So what I'm going to do is rewrite cotan x. Okay, so this is cos x over sine x. Okay, now I can flip the bottom one and multiply. So the top fraction is negative cosine squared x over 1, and I'm going to times by the flip of the bottom. So that's sine x over cos x. Okay, now this cos x can cancel with one of those. And then I get negative cos x times sine x. Okay, and that's as far as I can simplify. I'm in coses and sines, and there's nothing more I can do. So this thing simplified to negative cos x times sine x. Okay, so that's we used the Pythagorean identity, but then we also did switch to sine and cosine. So we didn't like that cotan was there. We thought maybe we can simplify more, so we switched to sine and cos. Okay, another technique you can use is to factor. Okay, so if your trig functions are squared or there's multiple, sometimes it makes sense to factor them. Okay, so for instance, here I have sine squared minus 1 over tan x sine x minus tan x. Okay, so we already know from the last one that this is negative cosecant squared. So that is one way we could go. But if I look at the bottom, I can see that there's a common factor of tan x. And if I pull that out, then I'm going to have sine x minus 1. Okay, and that is something that is related to this. Okay, so that's the way I'm going to go here. Okay, so let's see how that happens. So sine squared x minus 1 is tan x sine x minus tan x. Okay, so if I factor the bottom, I can take out a tan x, and I have sine x minus 1. So I can see on the top that it's a difference of squares. So it's sine x all squared minus 1 squared. So this will factor as sine x minus 1 times sine x plus 1. And now I can see that these guys cancel. So then I get sine x plus 1 over tan x, which maybe I can simplify further. So let's switch the tan x to sine x over cos x. Okay, and then I can flip the bottom and multiply. So I have sine x plus 1 over 1 times cos x over sine x. Okay, so I could bring this through to both of these terms. Okay, that's done. The first one, the sine x's are going to cancel, so I'm just going to have cos x. And then the second one, I'm going to have a 1, so it's cos x over sine x. And now cos x over sine x, that's cotan x. So I could rewrite this as cos x plus cotan x. Okay, so that's pretty simple. So I would say that's simplified. Cos x plus cotan x. Okay, but there's different ways you could leave it as well. Okay, another technique you can use is to create a difference of squares. Okay, so this is like if you have a plus b or a minus b, what you can do is, like what we did before, multiply by the conjugate. Okay, so this is, I'm just going to write here, like multiplying by the conjugate, which we did when we had square roots. Okay, now we're going to see why we might want to do that. Okay, so let's look at this one here. So I have sine theta over 1 plus cos theta. Okay, so let's just think about this. So there's nothing that can switch with sines and cosines because it's already in sines and cosines. I can't use the Pythagorean identity because nothing is square. I don't have sine squared or cos squared, or any of the other things squared. I can't factor this. Okay, so all the other techniques are out. Okay, but what I could do is multiply by a fancy 1. So what I'm going to do is multiply by 1 minus cos theta, because I have 1 plus cos theta. So whatever I do to the top or the bottom, I have to also do to the top. Okay, so this is going to be sine theta times 1 minus cos theta. But then on the bottom, I'm going to, if I expand this, I would get 1 minus cosine squared theta. Okay, so you have to FOIL it out, but it's special because it's a difference of squares. Okay, now the reason I want to do that is because now I can use a Pythagorean identity. Okay, so let me just write this up here. So we know sine squared theta plus cos squared theta is equal to 1. So that means sine squared theta is 1 minus cos squared theta. Okay, and I have 1 minus cos squared theta, so that's equal to sine squared theta. So I can replace that. So this is sine theta times 1 minus cos theta over sine squared theta. Okay, now this sine theta can cancel with one of those. And I have 1 minus cos theta over sine theta. Okay, you could leave it like this, or I could break up this fraction. So it's 1 over sine theta minus cos theta over sine theta. And these are both trig functions, so this is cosecant theta minus cotan theta. Okay, so that's, you could also simplify to that. Okay, so I could write that here. This is cosecant theta minus cotan theta. Okay, so those are some techniques you can use. There's obviously more than just this, but these are common ones that we use in this class. So I'm going to leave the remaining examples for you to try. Now here, we've given them as identities. Okay, so at the end, I wrote what the identity would look like. So that's what now you know what the end is supposed to look like. So you want to use all the same techniques. Okay, so begin on one side. Okay, usually the more complicated side is going to be better. And rewrite it until you arrive at the other side. Okay, so for this one, I would start with this side because it's more complicated than that side. So start with this side and simplify until you get to secant theta. Okay, so same idea here. This side is the more complicated side. So start with that side and then try to simplify to get the other side. Okay, and there's 4 examples for you to try here. It's nice when they're written as identities because then you know how far to simplify. Okay, and it is possible to simplify both sides at the same time and try and arrive at the same expression. But you want to be careful with that you don't start moving things across the equals. Okay, so I prefer if you just start with one side and then go to the other side. Okay, so those I'll go through in a subsequent video, but I want to give you a chance to work on them yourself.